key features of distributed testing in Gradle Enterprise. It uses single machine parallelism when no agents are available. So that means even if you don't get any remote agents assigned, your build should never be slower than if you just had used max parallel forks in Gradle. Enabling it is really simple. It requires a simple change to the build script. So there's no complicated setup. You don't have to, for the CI fan out, for example, this takes a lot of effort to set up and maintain. For this, it's really just a simple change to the build script. The test set is partitioned automatically for you, so you don't have to worry about that. And it works for local and CI builds. This is a major benefit. So you can now actually run local tests that run on different operating systems right from your development environment. No need to go through CI. The test reports and build scans, as we've seen, they show the results of all the tests. Yeah, if you have CI fan out, for example, you would get a build scan for each of these executions on each of these nodes, and there would be no aggregation. And the same is for test reports. You have to worry about that somehow to manually transfer these files back at the end. Of course, there are some tools that do that, but this is now really integrated. It's seamless. You don't have to do anything. And information about used agents is available in the build scan that will help you debug in case there's a failure that only happens on an agent. You will be able to see on which agent was this executed, and yeah, that will help you to find out and get to the root cause. Outputs are also transferred back to the build and merged automatically, so that, for example, for Jacoco, you will get an aggregated code coverage at the end without configuring anything. We handle that case transparently for you. Agents can be selected using requirements specified in the build, and specifically this means different test tasks, as we've seen, can have different requirements and run. Yeah, the selection happens basically in the build. You don't have to worry about configuring this test task to only run on this agent kind, on this other one, on this other agent type. This is all handled in the build. And last but not least, this all runs on premise on your own infrastructure. So that means both the agents run on your own infrastructure, the Gradle Enterprise server runs on premise, and your builds run on your developer machines or your CI agents. So everything is inside your network. You don't share any information you don't want. Yeah, so that brings us to our final poll for today. The question is, where do you see the most value in deploying distributed test execution in your environment? Let me open that. Yeah, now I should have it. So let's give it another few seconds. We've about 80% now. %, I think, doesn't go any further than that. 84%. Okay, close this and share the results. Okay, only 1% said I don't see any value. That's cool. I'm not sure. Well, okay, enough. Speeding up feedback cycles for local builds, only 18%. Speeding up local and CI builds, 57%. Cool. Making CI builds faster, mostly 15%. Cool. So I think that's really significant that also local builds can benefit from that. It's not just a CI thing, and yeah, it can really change your workflow also as a developer locally. All right, let's go back to the slides. There we are. So kind of to sum this up, if you have ever visited the Gradle.com website, you probably come across this statement here, that build caching and build scans can give every developer back an hour a day. And I believe now that we add distributed testing to the mix, I think we can even change that. And I think we can say we can give every developer back 2 hours a day. And I think that would be a very motivational, inspiring goal to have not only for me as a developer at Gradle, but for everyone really being excited about faster builds, faster feedback cycles, and increased productivity. Yeah, I hope some of you are asking yourself now, how much faster can I make the feedback cycle in my own build? And the question to that really is, well, there's no silver bullet. You just have to try it. You have to really try to get the most out of it. And for that, we will help you, right? You can request a free 30-day trial of Gradle Enterprise. And this is not some salesperson telling you what to do. This is really an onboarding with a Gradle domain expert. That means in case of test distribution, it's probably going to be Benedict or me, right? So we will really help you get the most out of this. And in this free 30-day trial, you can request on the Gradle website. Yeah, you can already let us know that you're interested in test distribution. So even though it's not yet released, we can note that down and get back to you. Or of course, there are other features in Gradle Enterprise. So if you're not already a customer, that might be interesting to also try build scans and build caching and see how far that can help you. Yes, and with that, I would like to open it for Q&A. I believe Benedict has already pre-scanned the question list a bit. And just a short note, in case we don't get to your question for some reason and you really want to know, please send us an email and we will follow up on that.
Yeah.
All right, Benedict, what's the first question?
There's like a ton of questions.
Okay.
So it looks like we got people excited, and there were also some people saying that they liked what they saw. Thank you for that. So there are some questions regarding Android. How does it work with Android? Can I use it in Android Studio? Maybe we go with that first and try to answer this whole topic.
Yeah, so Android, yeah, I mean, of course, if you just have regular unit tests, they will work. If you have any kind of Espresso UI tests that run on the device or simulator, we will not support that initially, right? There's already existing solutions out there that can run your tests on a farm of devices, so we're not yet competing with that.
Okay, so here's the question. Does it work on all JVM languages, Scala, Java, Kotlin, Groovy? Yes, as long as they use the standard test task and as long as they can execute tests on JUnit platform. Then a lot of people asked about additional infrastructure. They have integration tests where they need to spin up databases. How can that be handled in distributed testing?
Mm-hmm. Yeah, so basically what we showed was you can have these capabilities on the agents. You can, of course, set up the agent and install the database in addition to the agent or any kind of other thing. It also works, I think I saw that question. If you have some native dependencies that you need, you have to you can pre-install these there and yeah, just tag basically the agent using these capabilities and then express those as requirements in your build. And Gradle Enterprise will make sure that you only get assigned matching agents for that requirement. So let's make it concrete. If you have a database, you would say, I don't know, you need Postgres, and then you would have an agent that has that capability. The administrator who set up that agent has installed Postgres in addition to the agent and specified Postgres as a capability when starting the agent. And then in the build, you would specify that Postgres string as a requirement. And then Gradle Enterprise would make sure you only get agents assigned that have a matching capability.
Okay, a question that goes kind of in the same direction is integration tests that need to start Dockers would work. Any example? So this depends a little bit on how you start your agents. If you use, for example, the Docker-based deliverable that Mark talked about, so starting the agent in Docker, you will have to make sure that the agent process inside the Docker container can actually start a new Docker container and figure out how the tests running inside the Docker container can connect to the other Docker container. So there are a few patterns how to do that. I recommend reading that up, for example, on the test containers website. But that really depends on how you set things up.
Yeah, I think that's the same problem if you run those Docker things on a CI agent that runs inside Docker, right? It's the same underlying problem.
Then there are a lot of questions regarding pricing and licenses. We are just engineers. We can't tell you anything about that. Just get in touch with our salespersons, and then they can figure out the details with you. There are also some questions regarding auto-scaling. Does this connect to my Kubernetes cluster? Does it do the same thing as the Jenkins Kubernetes plugin?
Yeah, so we will provide an endpoint kind of where you can get the queue length, for example, maybe some other metrics that you can use to make scaling decisions. I cannot promise that it will be in the first initial version, but yeah, we're happy to have that conversation with you and then figure out exactly what you would need and then build that. Yeah, so it's not yet fully developed in terms of auto scaling. Has not been our top priority so far. But okay, we will provide a solution at some point.
More and more tests are coming in. Let me just have a look. Okay, auto scaling, we talked about that already. Okay, this is a tough one, I guess. I don't have an answer to this, but maybe we can try to figure it out together. How would this work where tests need native C++ libraries? So I guess...
Well, it depends if those are kind of static and can be pre-installed maybe, or are the same then and can kind of be detected. It depends on if these native libraries are built kind of in the build, I would say. So it's hard to tell. I mean, if they can be pre-installed, then it's a no-brainer. Then we can use the same capability requirement mechanism that we have in place. So we can put those native libraries on that agent and then use them. If it's something you build yourself in the build, so it keeps changing, you would need to declare that as an input. And yeah, so that would mean they would get transferred automatically. But then, of course, you have the problem that your build machine might not be running even on the same operating system as your native library. So yeah, I'm pretty sure we will be able to find a solution for that. Yeah, but we don't have a prepared example as of now.
Yeah. Somebody is asking about JVM versions in a situation where a test needs multiple different JVMs. So actually the agent, when it starts, it tries to figure out what Java version it is running on, and we have some convention for environment variables. And if you set those and let them point to an additional Java home, the agent will detect that as well. So for example, let's say the agent runs on Java 11, but you have Java 14, for example, you set an environment variable and the agent will automatically set the capability that it can also run tests with Java 14. Okay. Oh, this is one for you, Mark. What logic does it use to decide how to separate the JUnit suite into the different groups? And there were other classes about, other questions about the runtime of the tests not being equal as in our demo project. What do we say about that?
Yeah, we will have a solution for that. The project we've shown has just, test classes that all take the same time. That's not very realistic. Of course not. It was good for the demo. But it's something we have to take care of course. So we will record the execution time of test classes, and then we will use that information to partition the test set into sets that have approximately the same length in terms of execution time, and those will become the partitions. Yeah, that's what we're going to do.
Somebody asked, what prevents Gradle to use this technology beyond test tasks and move towards remote build execution? Well, that's a very broad topic. Actually, we talked about things like distributing a whole build, but there is a whole lot of problems. So we decided to focus on test execution at first, because this usually dominates build times. And so we are thinking about it, but there's nothing on our roadmap as of now to implement remote build execution. Okay. I think there are a lot of things that we already answered. Somebody asked, what about custom test frameworks that use tests that are implemented in XML? Again, if you can execute those tests on JUnit platform, so if your custom test framework has an engine for JUnit platform, then it would work on with test distribution.
Or is it if it has a JUnit runner as well? So everything that can run on JUnit 3 or JUnit 4 or JUnit 5, we can run. If you have, basically the requirement is you would be using the test task already, and those files, those XML files, would be kind of on the test runtime class path automatically. Maybe they are in source test resources, or if they're in some other location, they would have to be inputs of the test task, and then we would transfer them automatically to the agent and run them from there. So that should work out of the box.
Another question for you probably. How does this work with parameterized tests, generating large set of test inputs?
So I'm assuming this question goes in the same direction of test classes having a very different runtime. So I could imagine this parameterized test class having lots of tests and taking a long time to run. And yeah, that we would detect in the same way. We would track the usual execution time for that parameterized test class, and then yeah, use that to make a partitioning decision on that. And then yeah, it should work out in the same way as I said before.
Somebody asking about transferring of inputs. What is the performance like on the first build, where many agents need to pull the inputs from the build machine? Many thinking about for local developer builds. So this depends on what has been run before. So usually you have this the static set of things that doesn't change very often, like your dependencies. So all the jars will likely be available on the agent already, and then only the changed classes and tests will be transferred. But if you have like a cold start, you start a new agent, this might take some time depending on how big your class path is and how many artifacts you have to transfer. But as I said during the demo, it will never be slower as running locally, because your local executors will already start working through the test petitions. And it might even be the case that all petitions are finished until before the last agent becomes available. But that's also okay. Then it will be released right away. Okay. Somebody's asking, I saw JDK requirement mentioned somewhere, but I could not recall. Is Java 8 sufficient? So Java 8 is sufficient for the plugin. If you want to use it inside your Gradle build, you can, of course, execute tests within. No, you can only use Java 8 because you need to use JUnit platform, and that requires Java 8. So on the build side, Java 8 is a requirement. The agent runs on Java 11.
Yeah, for the test runtime, you can use any JDK starting with Java 8 because of the JUnit platform requirement. So, I mean, Gradle, I think, still supports Java 6 runtimes for test execution. So test distribution does not. You have to have Java 8 at least.
Okay, here's a question about Jenkins, I guess. When running JUnit in CI, XML files are produced. These XML files provide information about the test, its status, runtime, etc., and are used by Jenkins plugins to publish a report of the tests. Will these XML files be transferred from the Gradle slaves back to the Jenkins slaves so that they are available for the Jenkins plugins to be used?
You want to take that one, or shall I?
No, go ahead.
Okay, so yeah, actually for Gradle, these XML files are actually produced on the build. So they will be produced on the build machine, on the Jenkins slave in that case, directly. If they were outputs that would be produced by the agent or by the test execution, they would be transferred back automatically. So if you, for example, have some custom reporting framework that kind of hooks into the runtime of your test execution, maybe it's a Java agent or something, and produces some files, as long as you have those files declared as outputs, we would send them back. For the special case of these XML files, those are produced by Gradle, and yeah, they will be in the same location as always, and nothing will change